Hey everybody, Mr. Sharkey back with another exciting chemistry video. Today we're going to look back at Unit 6, Worksheet 2, excuse me. And last class, either in person or watching Mrs. Cat's video, for those of you following along at home, we started filling out Unit 6, Worksheet 2. And let me just briefly review what we did there. We started off by looking at some ions. So we looked at calcium ion. We said that would have a charge of +2. And then we looked at the bromine ion, which would have a charge of -1. And we wanted to try to predict what that compound would look like. And then we tried to write out the formula unit for that new compound that we created. So we said, in order for the charges to be balanced, I would need 1 calcium and 2 bromines, because that would give me a total of 2 positive charges and then 2 negative charges. So when those ions come together, we create a neutral compound that has the formula CaBr2. We looked at these first 4 examples, so let's just look at those again. We ended up with FeCl2, K2SO4. I've been encouraging my students, anytime we have a polyatomic ion, to write it in parentheses. You don't have to do that. Technically, you're not supposed to, but I think it gives us a good idea of where those polyatomic ions are coming up. As we're getting used to them, I think it's a good idea just to cue in your head, oh, that's polyatomic. And then we have AlNO33. And as you look at these formulas, it's pretty easy from the formula to tell what's going on. But those aren't really names for these compounds. So today we're going to review how to come up with names for these first 4. So you all have gotten some materials about naming compounds, and hopefully you've given these an attempt. But let's look through these first couple together. To start off, let's look at question number 1, CaBr2. When we think about Ca, we know that that is calcium. The first thing that I want us to check, if we switch over to our periodic table, remember that we have a couple different areas. Right now, I'm going to go ahead and highlight everything in yellow are our metals. And then everything that I highlight here in blue are our nonmetals. And then we have the metalloids as well, which I'll just leave white for now. When we are looking at the periodic table, we can divide these groups down a little bit more. And that's why there's a couple different periodic tables on here. If I scroll down to the bottom of my periodic table, we see this section down below, which is focusing on something called the transition metals. So all these metals that are in the center of the periodic table, I'm going to go back in and I'm going to highlight them green, just this whole section. These metals can sometimes have multiple different charges. If we scroll down here, we'll see which metals can have multiple charges. So if we look at something like chromium, chromium can have a charge of +2 or a charge of +3. If we're talking about a transition metal, we need to be specific about what charge it has. This first question is asking us about calcium. Calcium is not one of those transition metals, so we don't have to do anything special. So in this first example, as a reminder from our notes, we're going to start off by writing out the name of the metal. So this would be calcium. And then we're going to follow that with the name of the nonmetal, but we're going to change the ending to IDE. So this will be calcium bromide. All we've done is we've taken bromine and changed that ending to IDE. Calcium is always going to have a charge of +2. Bromine, when it becomes an ion, is always going to have a charge of -1. So since those are always going to be true, we don't have to do anything special with our name. Let's look at the second example. Now we're talking about iron. When I'm looking to name iron, the first thing I want to do is look back at my periodic table. If we find iron, it is one of those transition metals. So that means I want to scroll down to this second section of my periodic table, and we want to find iron again. If our iron has a charge of +2, we would call it iron 2. If our iron has a charge of +3, we would call it iron 3. So we need to keep that information in the back of our head. When we come back and look at our iron, this iron has a charge of +2. So we can't just call this iron. We have to say that this is iron 2. And then to name the nonmetal, we have chlorine, but we need to change that ending to "ide." So it'd be iron 2 chloride. And that would be the name of our compound. Again, we know that chlorine ions have a charge of -1. Because we were specific, we know that the iron 2 has a charge of +2. And that helps us go back and figure out what our formula was. Two more examples. I'm going to try to go through these ones a little bit faster. Potassium, if we look on the periodic table, it is not one of our transition metals. So that means we can just write out potassium. We always know that potassium will have a charge of +1. But now we have a polyatomic ion, this SO4. So to figure that out, we're going to go back to our periodic table. And this one copied over weird, so I apologize that this polyatomic ions is kind of floating in the middle, but we'll try to make it work. So I'm looking for SO4. So I want to scan my document. Oh no, it's if we look in here, hopefully on your periodic table it's clearer, but we can see that there's an SO4 here and it has the name sulfate. So I can pop back to my naming, and this SO4 polyatomic ion is going to have the name sulfate because we found it on our periodic table. We know that sulfate is always going to have a charge of -2, or you could say 2-. Last example that we're going to look at together, aluminum. If we look at our periodic table, aluminum does not fall into that transition metal category. It's close, but if we look down at our secondary periodic table, we see aluminum's up here, it's number 13. But when I scroll down, there is no special naming for aluminum. So that means that we can just start off with aluminum. Aluminium, if you're from across the pond, which will have a charge of +3. Because aluminum always has a charge of +3, that means we don't have to call it aluminum 3. We don't have to add anything extra. We only do that for the transition metals. But now I need to look for NO3, so I can go back to my periodic table, scroll down to my list of polyatomics. We can find NO3 down here. It has the name nitrate. So I can, went too far back. I can come back and I can fill in that this is aluminum nitrate, which has a charge of -1. So that tells me I would need 3 nitrates to make a balanced compound. So in case you were struggling with the naming rules, hopefully this video helped you out. Right now we're only talking about ionic compounds, so there's a couple things to keep track of. If we have a transition metal, so if the metal can have multiple charges, you need to be specific. For instance, we said that this was iron 2 because it had a charge of +2. And then if you're looking at a polyatomic ion, you don't change the ending. You just need to look up and figure out the name of that polyatomic ion. And that's how we ended up with sulfate and nitrate. Following these rules, you should be good to go on the rest of the worksheet. If it's a normal metal, just name the metal. If it's a normal nonmetal, just change that ending to IDE. Transition metals have a special rule. Polyatomic ions have a special rule. Try to name the rest of 1 through 10, and then you should be good to go. Thanks, everybody. Have a nice day.